Welcome back to section 2 of chapter 3. In this section, we are going to be looking at derivatives of exponential and logarithmic functions. So we're going to see how to take the derivative of another type of function. It's not the product rule, quotient rule, chain rule, which is used with everything. This will be something that will be used with those things. It's kind of like a trig, where it'll almost always be with chain rule, plus now that we have the other ones, it'll largely be with those as well. So if we start out, we want to look at the derivatives of exponential functions. And so exponential derivatives, there's two of them. I have four here. We have the derivative of just a number to a power, and then specifically e to a power. The bottom two just include the chain rule option. And so those are like the more generic, the more general. But typically, or basically, if you have a number to a power, you get that same thing times the natural log of that number. So for example, if we wanted to find the derivative of 3 to the x, that's going to be 3 to the x times the natural log of 3. That's it. The cool thing about e is the natural log of e is just 1. So the derivative of e to the x is e to the x. It is its own derivative. That's awesome. That is why e is my second favorite irrational number. And so obviously you're not going to get e to the x too often. I mean, you will when we get when we're starting to do applications and stuff like that. But today you're not going to get e to the x. You're going to get things like f of x equals e to the x squared plus 3x. So the derivative is going to be the same thing, e to the x squared plus 3x times the derivative of the exponent, 2x plus 3, and done. We can have chain rule with the normal ones as well, like the not e. We could have, let's say, f of x equals, let's go 5 to the negative x. So the derivative, it's still going to be 5 to the negative x times the derivative of negative x, which is negative 1. So this we could just rewrite as negative 5 to the negative x. And so that's exponential functions. Natural log 5, natural log 5, natural log 5. I just illustrated what I was about to say, where the most common mistake is to forget the natural log. You want to do, it's going to be the exact same thing as it was, times the natural log of the base, and then times the derivative of the exponent if that's something that also has to happen. So those are exponential functions. Logarithmic functions, we again have two. We have a normal base, just a regular whatever base we want, and we also have base e, which is the natural log. So when it's just any base, it'll be 1 over x times the natural log of that base. The derivative of the natural log of x is just 1 over x, because again, natural log of the base e is going to be 1, so that goes away. So if we wanted to do some of these, we have f of x equals log base 6 of x means the derivative will be 1 over x ln 6 times the derivative of x, which is just 1. We could have something with a little bit more to that. We could say f of x equals log base 5 of x squared minus 1. And so our derivative, we're going to have 1 over x squared minus 1 ln 5. Don't forget that natural log. That's, again, one of the common mistakes. And then times the derivative of our x squared minus 1, which is 2x. And we could move that on top if we wanted to. So we have 2x over x squared minus 1 natural log 5. And then if we want natural logs, well, natural log of x is just 1 over x. Let's look at f of x equals the natural log of x squared plus 2x. So the derivative here is going to be 1 over x squared plus 2x times the derivative of x squared plus 2x, which will be 2x plus 2. And then again, that could be written over top. 2x plus 2 over x squared plus 2x. And then you could factor if you can. In this case, it's not going to factor, but sometimes it will. Let's look at one more. F of x equals natural log of x to the 5th. The derivative here is going to be 1 over x to the 5th times the derivative of x to the 5th, which will be 5x to the 4th. Well, this can simplify a little. We have x to the 4ths. I'll get rid of that and that. And so we're left with 5 over x, which you might be thinking, wait, that's kind of weird. We could rewrite our original equation. That exponent go out to the front. This is the same as 5 times natural log of x. The derivative of natural log of x is 1 over x. So that's going to be 5 over x. And there you go. If you have x to a power, or the natural log of x to a power, the derivative will be that power over x. You'll be actually looking at some patterns here. Things like natural log of 5x, what's going to happen to that, and things like that. And the fun patterns pop up in some of these. Anyway, this is what you're working on. Derivatives of exponential functions, derivatives of logarithmic functions. In there, we'll have chain rule, we'll have product rule and quotient rule practice that uses exponential logarithmic functions, and just a whole bunch of other great stuff. We're starting to get into where we're doing more fun stuff. It's not quite as tedious, and I enjoy it at least. So anyway, keep working problems, keep asking questions, and as always, happy mathing.